Hello, welcome. Let's try to solve another Leetcode problem, 794, valid tic-tac-toe state. And this is a design problem actually. Yeah, even we need to check if it is a valid condition. We need to prepare a lot of things. So the player is like that. So the first player will use X, and the second player will use O. As you can see, there's only O on the board, so we're gonna return a false immediately. And for this example, there are 3x, and it cannot be like that. So it can only be like 2x, 1O, but it cannot be 3x, so we're gonna return a false. And this is a valid state. Yeah, we just need to check this final state. So as you can see, with x first and O, it can have this kind of state. Even there's no winner, but this is a valid state. We're gonna return a true. So the length and row and column is only 3. So this is not like a time complexity problem. We don't need to check the time. We just need to check the logic. So I believe this is a design problem. We need to design the right logic to make it work. Yeah. Now let's just get started. Yeah. So I think the numbers is important. So the number of O and the number of X is important. As X starts first, so I'm gonna first design the number of X and then the number of O. It's gonna be 0 and 0. Yeah. So if I know the numbers, I think the numbers is important. Is easy to check. So let's just define a variable n. It's gonna be the length of the board. Yeah, because row and column is the same, so I only use n. So for r in range n, and for c in range n, I just need to check the board. If the board are c equal to x, it means the num of x would plus equal to 1. So if the board are c equal to O, so the num of O would plus equal to 1, because there's also empty string, so we have to check the if and elif like this. Now we have the numbers. Yeah, we can directly check that. So the numbers of O can never be bigger than the numbers of X. Yeah, so it means if the nums of O more than nums of X, we can return a false immediately. So this is one condition, like this example. It can never happen. And let's check the second example. So or the number of O plus 1. Yeah, let me use the number of X first. Or the number of X minus the number of O more than 1. Yeah, so this is more than 1. 3 minus 1, it is 2. 2 is more than 1. Yeah, if it is equal to 1, it is still okay. But if it is more than 1, so we're gonna return a false. Yeah. Now let's just check the first two examples to check if this logic is right or wrong. Yeah, as you can see, the first two examples works. Yeah, this is just for the first two examples. So for this 3 and 4, it just works, but it didn't work for all other examples. You should know about that. And because for this logic, I'm just checking the first two examples. I mean this one and this one. It means the first two examples work. But what if the conditions are like this? The example 3. Yeah, so we have to check if the number of X. So we have to check the last state. So the last state is X or O. It always depended on the numbers of X and the numbers of O. Yeah. So what I mean by that, so if the numbers of X equals to the number of O, so what is the last state? What is the last player? It must be this O. Yeah. But what if the numbers of X is more than numbers of O? So for example, number of X equal to 5 and the numbers of O equal to 4. It means the last state must be the X. Yeah. Yeah, because after that, after this false check, we basically have two conditions. We have to check which one is the last state. Yeah, now let's just check the last state. So if the number of O equal to the number of X, yeah, even it is equal, we have to check the conditions. But even it is equal, it can be a false. Why? Yeah, I mean, how many O's and how many X? If it is a valid condition, we can put it on the board. So the maximum number of X can only be 5. It cannot be 6. Yeah, so you should know about that. It means you you cannot put conditions like that. Yeah, it's gonna never happen if the conditions is like this. Yeah, I mean the numbers. If it is like this, we're gonna return false immediately from here. Yeah. So currently, while we are considering the other two conditions, it will never have this kind of condition. Yeah. So if the number of X equals to numbers of O, yeah, like this example. So this means what could be the possible winner? Is X or O? Yeah, because the last state is O. So yeah, the condition is that only O can be a possible winner, but definitely X cannot win. X must not be a winner. Yeah. So we're gonna, yeah, X must not be a winner, and this winner must be this player O. But we need to return a false. Yeah, but what if X is a winner? So we're gonna return false, because X cannot be a winner if they are equal. Yeah, so we're gonna check the X. So if win inside, actually this is for X. If X wins, so I'm gonna return a false. And another condition is that, let me just copy the code. Yeah, if the number of O plus 1 equal to the number of X, yeah, this means the X must be a possible winner. It can win or cannot, but the O must not be a winner. Yeah, but what if O wins? If O is a winner, we're gonna definitely return false. Otherwise, except all those conditions, we're gonna return a true. Yeah, so this gonna be the final code. But we didn't finish this win function. But how can we write this win? Let me put it here. Yeah, definitely we're gonna write this win function. Yeah, this win function is just a winner check if it is a winner or not. So this is similar like Leetcode problem 348, just a validation check. Yeah. Now we can write it. Before that, we're gonna define some variables. Yeah, let me put it here. So we're gonna use row X. This is just a set, and column X, and diagonal X. So it's gonna be the default dict, and it's gonna be the dictionary. Yeah, let me just copy and paste. Yeah. Now let's define the another 3 dictionaries for the player O. So we're gonna use this O. Yeah, and here we're gonna use this O. Yeah. So finally, we just need to put it inside of the set to check if it works. Yeah. So this winner function is just we're gonna check 3 sets. We're gonna check the values of those 3 sets. So this is just a validation check. So if win list row dot values, yeah, values plus list column dot values and plus list dot diagonal dot values. Yeah. So this is a 4. Yeah, now we just need to check if this v equal to n. So we're gonna return true, otherwise we're gonna return false. So yeah, otherwise we're gonna return false. If there's no true, we're gonna return false. So this is just a winner tag. Which player gonna win? Yeah. Now we need to put the values inside those set. I think it's gonna be much easier. Yeah. Now if it is x, so it's gonna be the row set with x with r, so the plus equal to 1, and column set with x, c would plus equal to 1, and we also need to have a tag if r equal to c, so the diagonal x with 0. Here I just define it as 0 as the diagonal and 1 as the anti-diagonal, so it would be plus equal to 1. And if r plus c plus 1 equal to n, this is the anti-diagonal, so the diagonal 1, so the plus equal to 1, and this one gonna be the x. Yeah. And similarly, I'm gonna copy the code to here. Yeah. And change this to O. Yeah, I think this is enough for all the validation tags. Yeah. Now I just need to run it and check if it works. And the time complexity, I don't think we need to analyze such time complexity, because basically this n is 3. Yeah. There are 2 for loops, and yeah, there are 2 for loops, n square, I think. Yeah, because this is just a tag, win x or win O. Yeah, so we need to put the x inside. It means those 3 sets. This means x wins, and we put the O's inside. So this means the player O gonna win. Yeah, now let me run it to check. Yeah, as you can see, it works. Now I think it's enough to submit it and to check if it can pass all the testing cases. Yeah, as you can see, it works and it's pretty fast. Yeah, because this n is just 3. And for this problem, basically we need to write a lot of sub-functions to check. And basically, I think this is a logic problem. It is like a design problem to check such kind of conditions. Yeah, so the first condition is easier to check, except the first one. There must be 2 other conditions, and we have to check the 2 other conditions. And the false is easier to check than the true, because there will be more conditions for the true. So we're gonna check the false. So except the false, it's gonna be the true conditions. Yeah. Thank you for watching. See you next time.